Okay. Now we'll come back to calculus and linear algebra. Today we will talk about second order differential equation, but non-homogeneous. You remember last session we discussed the second order differential equation, which is homogeneous, coming in this way: a y double dash plus by plus dash plus cy equals 0. This is homogeneous, as you can see here, 0. But when there is function to the right hand side, we have non-homogeneous. So how we deal with non-homogeneous? It seemed to be the solution for non-homogeneous differential equation y will equal to y1 and y2. It means two solutions, we put them together to get the solution for the non-homogeneous differential equations. These two y's, the first one is the homogeneous solution of the equation. It means the one we just discussed last week. We call it complementary function or homogeneous equation. I will explain definitely with examples. But the second one, the new one, is the particular integral or particular solution. Let me show you an example using this example. Have a look. He gave me this equation. I understand that this is a non-homogeneous because I have x squared to the right hand side. I will come first to find the complementary function or the homogeneous solution. I will say, okay, d square y over dx square, it means m square, minus 5 dy over dx, it means 5y, it means 5m, plus 6y, it means 6 equals 0. This is the homogeneous, right? We solve it. We go for factorization or quadratic formula. We put m here, we have 6, which is coming from 3 times 2, we have plus, but here minus, then we have minus, check minus 2 by minus 3, 6, minus 2 plus minus 3, 5. Okay, so I can say m equal 2 and m equal 3, which tell me that the solution for the complementary function, the homogeneous function, is two roots, different, real. So I will come to write the solution y1. The first part is constant exponential, the first root x, plus constant exponential, the second root x. This is clear, discussed last week. What is the new? The new, to find y2, the particular, let me say, integral or solution, is gonna be done using the following equation. By the way, I want you to remember x square, our function here, x square. Have a look. You are given table. In this table, you will check the function f of x to the right hand side. If the function is a constant, then the assumption y to be constant. Any c, whatever you call it, k naught, whatever you call it. If the function constant times x, it means polynomial from the first degree because x rises to power 1, I will write the solution in this way: constant d plus constant c times x. If it is kx square, it will be constant plus constant x plus constant x square. Polynomial, you open it. By the way, I use c, d, e. You can use any, let me say, simple for these constants. If it is sine x, k sine x, the function, or cosine x, the solution will be constant sine x, constant cosine x. If it is the function is sine hyperbolic x or cosine hyperbolic x, the solution is. If it is exponential, oh, it means I look to the right hand side and try to pick my formula from here. Yes. As example, the previous equation we are solving now, the right hand side is x squared. So I should take this solution. I will say yp equal this part, as you can see here. You see x squared, y equal c plus dx plus e, let me say, x squared. Now I will substitute this one here. I need y dash which means dy over dx. Then I will do differentiation for this. It will be 2ex plus d. I will take it and substitute it here. I need y double dash, then I will differentiate again. Y double dash equal 2e only. I will take it and substitute it here. So when I substitute them, as you can see here, equal x squared. Where is x? Where is the constant? They are not there, then it means they are multiplied by 0. Now what I will do, I will look to this equation. Let me clean it, okay? It's not clear here, okay? Just a minute. Okay. Now let me back. Have a look. I will come to say the equation left-hand side x parameter or x square parameter should equal to right-hand side x square parameter. It means here we have 6cx square. It's supposed to equal 1x square, which means that if I can say here 6c equal 1, I can find c. Okay, now this is for x square, as you can see here. For x, I will say all this part equal to 0. Great, equation with 2 unknowns, but see, I got it, so I can find it. Great. Now, this constant equal to 0. I got C, D, then let me find E. When I find them, I come here to substitute for them. So I got the second part of the solution, which is the particular integral. Now the final solution is adding these two together. The final solution is y1 plus y2, which is y1 already we got it from the homogeneous equation solution. And the second one is the particular integral or particular solution. Now let's take another example. I'm given this equation here, y double dash, it means m squared plus 4 equal 0. So I will solve, but just a minute, he didn't ask me to find the homogeneous, only the particular. Okay, then particular, I will come to say, okay, this one x squared from the table, I go to the table, it is constant, I change the constant name, I make it k naught, k1, k2. Okay, you can say call it c1, c naught, c2, and so on. Okay, constant times x, constant times x squared. This is y. I will substitute it here. I need y double dash, so I differentiate it again twice. It will give y double dash equal to k. Then I take it, I substitute it here. Okay, as you can see here, we simplify. Now have a look. This is x square, and here x square. Their parameter should be equal. It means 4k2 should equal to 8. I get k2. Now there is no x here. There is no x here. So it means 0. It means plus 0x. So 0 should equal to 4k1. It means k1 is 0. There is no constant, plus 0 it means. So this part should equal to 0. I have k2, let me find k0. When I got them, I come back here to substitute for k0, k1, k2. This is the particular solution. This is another way to show the same previous table. You have the function. Look to the function. It is constant x to power n, then it is polynomial from n degree. So you break it down. It means constant x to power n plus constant x to power n minus 1 plus constant x to power n minus 2 and so on until you reach the constant here. If it is exponential, then it will be constant exponential the at, as you can see here, the same at. If it is sine, then it means sine plus cosine. If it is cosine, sine plus cosine. If it is exponential times sine, it will be exponential times sine plus cosine, and so on. If it is the same thing, exponential. So you pick it, you pick your solution from this column, which is the particular solution. Now, this is the general idea. We will solve definitely together more problems, but I would like here to highlight something. We have a few rules need to be considered in solving the homogeneous non-homogeneous differential equation. These rules are basic rule, which means we use it directly from the table. Modification rule, it means something wrong, so we need to modify. And sum rule, it means we have more than one function. Sum together, we need to consider this sum. I will explain this by this example. Have a look here. We have here this formula, which is y double dash minus 4y dash plus 4 equal 4x plus 8x squared, as you can see here. Now, this is the first part. I will take it side here to solve it as a homogeneous equation. So I wrote the auxiliary equation, which is m squared minus 4m plus 4 equals 0. This is a procedure. We discussed it before. I got the roots. Roots found equal, real equal, which is 2. Then I write the solution, which is constant plus bx times exponential, as we discussed and learned before last week. Now I put it aside. I come now back here to solve the non-homogeneous. Have a look at the right-hand side function f of x. It seems to be, it is polynomial from the third degree. So I will write from the, according to the table, it will be constant plus constant x plus constant x squared plus constant x to the power 3. You see, I'm keep changing their names, the constants. Sometimes I call them CED, sometimes I call them K0, K1, K2, PQR. It means it doesn't matter what you call them. At the end, they are constants, simples. Now, this is why I will substitute it here. I need y dash and y double dash, so I will differentiate. Differentiation of this will give q plus 2rx plus 3sx squared. I need another derivative. Derive again, then I got this one. Now this part will be substituted here. This part will be substituted here, and this part will be substituted here. I substituted, and then I start open the brackets, simplify, and equate x to the power 3 parameters on either side of the equation, x square parameters on either side of equation, x parameters constant, and so on. What I got set of equations. From this set of equations, you can see from the first one here, I can find s. Substituted here, you find r. Substitute s and r here, you find q. Substitute here and here, you find p. So you get these, let me say, constants. When I got them, I back to y here, substitute for p, q, r, s, where I got the second y, which is y particular. Y homogeneous or complementary, and y particular. Final step is to add them. I will marriage these two equations together. yc plus yb. I put them together. You can see here, this is the first one, and this is the second one. This is what we call basic rule. Another example on basic rule. Here you are given second order differential equation, but see the function to the right hand side. It is cosine. Oh, I know from the table, if it is cosine, it will be constant sine plus constant cosine. But let me first start with complementary function or homogeneous. I wrote here the characteristic equation. I solve it. I got m, which is 2 and minus 3. Then when I got them, I will write my homogeneous. This is half of the solution. It is a exponential 2x plus b exponential minus 3x. Done. This is the first part. Done. You see here? I wrote it here. Now, next, I will come to write the particular. Why particular? Yp? From where I got it from the table. I have the function here is cosine. If I go to the table, I will find it. It is c cosine 2. By the way, 2x. You see here? 2x. Cosine 2x plus d sine 2x. Now, I need to make first derivative and second derivative to substitute here and here respectively. So I differentiate, as you can see here. The differentiation of sine is cosine. Differentiation of cosine is minus sine. So I differentiated them. And then I came to substitute here and here, as I mentioned, and here y. When I substituted, I have two equations, as you can see here, with two unknowns, c and d. I can solve them simultaneously. Okay? So I got C is -5 and D is 1. Until this point, I got the second, let me say, what part of the solution, which is the particular integral or particular solution. I substitute for C and for D here. Then this is the second part. I will put it here as you can see. Now, until this point, is it clear? Is it clear before I go further? Okay. Now I will not solve the modification rule and sum. I will jump directly to the final, let me say, formula here. I would like you to solve which one? I would like you to solve this one. Okay. You see this function? Okay. I will make it in red. Just a minute. What I want you to do, find the homogeneous and then find the particular. You can start now and tell me when you finish the homogeneous. Start with the first part, homogeneous. When you finish it, let me know how much you got. Anybody found it? Homogeneous, what type of fruits we will have? Yalla, Hamad, Kauthar, Ali, anybody found it?
M
How much?
equal -2 and -3. So
Minus,
A
minus 2. A exponential minus 2x plus B exponential minus 3x.
yes.
Y complementary or homogeneous. Let me solve it. Let me solve it. I will come to say I will work here. M square minus 5m plus 6 equals 0. Open brackets. Okay. M here and M here. 63 by 2 minus minus equals 0. This gives me 2 and 3, 2 and 3, right? So plus 2, plus 2, plus 2. Make sure from the signs, please. You have wrong signs, you lose the question because minus is different from plus. Okay, now we got this. Now next, I will go for the particular. I will say from the table, yp, just a minute, this is sine. So I go to the table. The table tells me is it c sine 2x plus d cosine 2x. Okay, now I need to find yp dash and yp double dash because I will substitute. Okay, now let's go for the first one, yp dash. It will be sine 2x, it will be 2c cosine 2x. And this is cosine, it will be minus 2d sine 2x. Okay, differentiate again, it will be minus 4c sine 2x minus 4d cosine 2x. Are you copying what I'm doing? Is this clear what I'm doing here? Are you following?
Yes, clear.
Great, 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 great. Now I will
Yes.
substitute. I will substitute. Just I need space. Okay, I will. Just a minute. Keep. Okay. I will add another slide to work on. Okay. Okay. Now what we will do. Okay. Let me take this part. Are you following?
Yes.
You see the slide. You see the slide because I need space. Okay, you see the slide. Now what I will do for this y double dash, I will substitute this one. I will say it will be minus 4c sine 2x minus 4d cosine 2x. Next, minus 5, as you can see here, open bracket, okay? It will be, where is y dash? Y dash is this. It will be 2 c cosine 2x minus 2d sine 2x plus 6 plus 6 open bracket. I will use this y c sine 2x plus d cosine x. Okay, did I forget anything? I forget 2 here, right? I lose the question. You need to make sure, don't forget anything, don't miss anything. Now this minus 5 will be multiplied by here and here, right? So minus 5 by 2 minus 10, and minus plus 2 by 5 is 10. So let me use the, sorry. I will erase this part, minus 10, and here minus will become plus 10. Okay, no need for brackets. The same thing could be say for here. Okay, 6 will be multiplied by c and by d. So I will, okay, let me first erase this part, 6c and 6d. I will use here 6. This is equal what? Equal minus 3 sine 2x. Okay, now let me organize my work. Okay, now here we have sine, here we have sine, and here we have sine, and here we have sine. So we will come to say for sine minus 4c, okay, and here plus 10d plus 10d, and here 6c plus 6c equal how much here? Minus 3. You can see I got equation, and let me go for the second one, which is cosine. For cosine here and here and here, nothing here, it means 0. So I will say minus 4d, I will write it here, minus 4d, okay, minus 10c plus 6d equal 0. This is another equation. Two equations with two unknowns. Can we solve them? We solve them to find c and d. We solve them. This is one and this is the second equation. By the way, here you can say 6d minus 4d, it means 2d, right? So I will write it minus 10c plus 2d equals 0. And this one minus 4c plus 6c, it will give 2c. Okay, 2c plus 10d equal minus 3. So these are two equations. We will solve them to find C and D. Can you help me and solve them? Anybody got the solution? By elimination, by substitution, by Cramer rule, whatever method easy for you, go ahead. Help me in this. Take your time and solve it. يلا شباب، كوثر، حمد، البقية.
D equal first. D equal 5C.
5C. What you mean? Give me final answer. How much D, how much C? How much D? How much C? How much? What happened? Oh, I don't know what happened. I lose the. Okay, give me final answer. C and D. How much C? How much D?
C is minus 0.057 and
Minus
D is
0.
minus 0.288.
The first one is 0.057.
Minus 0.057.
Excellent. Now I will take them and substitute here. This is C and this is D. I will write the final answer. Y equal Y
E is
complement
also minus.
also minus. Yeah, there is
Yeah.
minus. Okay. YP. Then I will write it. YC is this one, which is A exponential 2x plus B exponential 3x. Now I will come to YP, which is this one. Whereas C, how much C minus? Okay, minus 0.057 sine 2x. This is the first one. The second one, D. What is D minus? Okay, minus 0.288 cosine 2x. This is the solution. This is the solution. Now, if I differentiate this, it will give me this formula. You got it? This is how we solve a non-homogeneous second order differential equation. The modification rule, the sum rule, to be discussed inshallah next session. I will stop here. I advise you to practice more. I gave you at the end of the slides a few exercises. Please try to work on them. Try to solve more problems. Do you have any question? I will stop until this point. Do you have any question?